Hey guys, this is Nurul Huda and I am an educator at an online learning app that is Unacademy. There also I am posting videos which are going to be very helpful for you for your CSI net preparation. So if you are enjoying my videos, if you are liking my teaching skills on YouTube, then I hope you will also like my videos on Unacademy as well. So follow me over there so that you don't miss out anything which I am posting there for your preparation of CSI net. So how you have to do this is just download this Unacademy learning app from the app store, and you have to search for my name, that is Nurul Huda, in the search bar, and you will get a screen like this which is shown on your screen right now, and you just have to click on this follow button to follow me over there. All right, and if you follow me, whenever I will upload a new video or anything, you will get notification for that. Secondly, you can also go over there, go to my profile directly from the link given in the description. So that's all for this. Let's continue with the video.
Hey guys, hello everyone and welcome to the channel. Now today's video is going to be about a very important concept, a very important topic from your inorganic chemistry, and that is your synergistic effect, or I would say that I will be focusing on this thing, that is stretching frequency of inorganic complexes. So how this synergistic effect is affecting the stretching frequency, that I'm going to talk about in this video. Now see, the stretching frequency, you will be you will be coming across with this topic in two forms. One is in your organic chemistry and one in inorganic chemistry. In organic chemistry, you will be given with certain more organic molecule, and you have to tell that what will be the range or where the frequency will, like the higher frequency will lie. Okay, for carbonyl ligand, like for CO functional group or any other functional groups are there, like aldehyde, ketones, carboxylic acid, based on them. Now in inorganic chemistry, you don't have to deal with those type of questions where you don't you don't have to remember the values. Here the things are little different. Here you are given with certain complexes and you have to tell the order of them. Okay, so you have to tell that in, like, what will be the order of frequency. Now that thing you can understand based on the electronegativity or the electron richness of particular metal center. Okay, so in today's video I'm just going to explain you all these things in brief, so that how you can approach these type of question. And I will not be going in that detail. Okay, I will not be going in the theory part of it. I'll be just telling you how to approach towards these type of question. Now one more thing, that in order, like, if you want to understand the theory part, if you want to understand the detail part of it, you can read the books. The books which I will recommend you is like Inorganic Chemistry by, like, Organometallic Chemistry by B.D. Gupta, or you can follow the book by Robert H. Crabtree, or you can follow inorganic like Organometallic and Bioinorganic Chemistry by Ajay Kumar. So these three books I will recommend you. You can follow any of these books and you will be getting these things in detail over there. In today's video, I'll just tell you that how to approach these type of question. Now before going into the question, I will just explain you few basic things so that it becomes easier for you to understand and it becomes easier for you to solve the questions. Okay, right. So first we will talk about this metal carbonyls. Okay, so like metal carbonyls, in here you will see a very different type of bonding. Here, like, there is a sigma bond between metal and carbon, whereas there is also a pi back donation from this metal d orbital and p orbital or vacant p orbitals of carbon. So there are two things which can happen. One is the electron can be transferred from filled, like if metal center is electron deficient, then flow of electron will be something like this, and if the electron if the metal center is electron rich, then it will try to move electrons something like this. So these type of movement which I am just showing is called pi back donation. So this is called pi back bonding. So this type of back bonding occurs when your metal is electron rich. All right, now if you remember, if you try to remember both of the things, that is like the electron transfer from carbon to metal and this pi back donation, then in order to solve question, in order to attempt a particular question, you might get confused. Okay, so I will recommend you to remember just one way, and the best way to remember it by the method of pi back donation. Okay, so just remember one thing very importantly, that is there is a pi back donation from if metal is electron rich. So if your metal is electron rich, it will donate electrons towards carbon, pi back donation. Okay, now similar things can happen if you have metal olefin complex. That is, that this was when metal carbonyls were there, means the ligand was CO ligand, that is carbonyl ligand. Now if the ligand is olefin, that is carbon carbon double bond containing ligands, then over there also you can have this pi back donation like this. Okay, so pi back donation can happen here also. Now what are the consequences of this pi back donation, that I will explain you using molecular orbital diagram. Now if you can see the molecular orbital diagram of CO, that is carbonyl ligand, carbon monoxide, over here the 6 electrons, 2 from carbon to, like I'm just showing the p orbital. Okay, so the valence p orbital, 2 electrons are in carbon and 4 electrons are there in oxygen. So total 6 electron, if you fill in the molecular orbitals, they will be filled something like this. So this is how it is done. And this is sigma bonding orbital, this is pi anti bonding, pi bonding orbital, this is pi anti bonding orbital, and this is sigma anti bonding orbital. Now if you try to introduce more electrons, if you are giving more electron, then the only possible place for it to stay is this pi anti bonding orbital. So that means if more electrons are added to this carbonyl ligand or carbon monoxide molecule, then they will go to the anti bonding orbital. Okay, now see what will happen when the back donation will happen, then how it will do. Okay, so when the back donation will happen from metal to carbonyl, like if the pi back donation is done, so at that time you are giving more electron density towards this carbonyl ligand. Okay, so you are giving more electron density to this. That means now your the excess of electrons, the more electrons which you are giving, they will try to lie in this anti-bonding orbital. Okay, so that means you are increasing electrons in anti-bonding orbital. Now the like the formula for bond order, the bond order of a particular bond, the formula for bond order is the number of bonding or electrons, okay, minus number of uh, anti-bonding electrons, okay, and divided by 2. So this is the formula for calculating the bond order of particular bond. Now that means if you increase the number of electrons in anti-bonding orbitals, if you increase the number of anti-bonding electrons, then what will happen, the bond order will decrease. If the pi back donation is not there, then anti-bonding electron will be 0. So you will be just having the number of bonding electron. Now if let's say two electrons are, like if the number of if the pi back donation will increase, the number of anti-bonding electrons will increase, and that will decrease the bond order. So just remember this series, this trend, that pi back donation is inversely proportional to bond order. So that means if pi back donation is more, bond order will be less. Okay, now the things are now related to each other. See how now this bond order is related to bond strength, like this, like bond order and bond strength are directly related, means they are directly proportional, and bond strength and bond length are inversely proportional. So yeah, so if the bond length is less, then bond strength will be more. It is something like this. These two are inversely proportional. Then your frequency, that is your like frequency of the bond, this the frequency of the bond is directly proportional to bond strength, or you would say that yeah. So I'm just talking about the frequency of carbonyl. Okay, so mu cu, or if you talk about the if you talk about that olefin bonds, then here it will come C double bond C. So the frequency of that thing, that is the ligand frequency, frequency of the molecules of ligand, stretching frequency, that is directly proportional to bond strength. So all these things are related. So now if you find out the relation between back donation and bond order, you can find out everything over here. Okay, so now the things become quite easy if you understand these things. Similar thing will happen in the case of olefin also, like metal olefin complex also. There also same thing will happen, just you have to understand the back donation, and after that you can find out the order of bond order. And what will be the order of bond order? That will be the same order for bond strength, that will be same order for stretching frequency, and that will be inverse of the order for the bond length. Okay, so this is how you have to relate all these things. So I'll just give you one question, I'll just explain you these things with the help of one question. Okay, so let's say we have this question, and this question was asked in GATE 2016. All right, so the question says that the correct order of CO stretching frequency is, and you are given with like different options where the order is different for you. So basically you are given with this complex, that is titanium CO6 2 minus is there. Okay, then you have vanadium CO6 minus. All right, then you have chromium CO6, and then you have free carbon monoxide. Now see how you have to understand, how you have to do these things. First of all, back donation, just find out the order of back donation. Now how back donation will increase? Back donation will increase when like pi back bonding will increase, or you can say that pi back bonding is directly proportional to electron density on metal. So if your metal is having more electron density, then that will have more pi back donation. And I already told you that pi back donation is inversely proportional to bond order, and bond order and frequency are directly proportional, so that means it will be inversely proportional to frequency as well. Now here in the question they are asking about CO frequency, so just it will be for CO. So since bond order and frequency are directly proportional, so you can write them like this. So how you got the order of this? That means electron density on metal is inversely proportional to frequency. That means in this complex, in the titanium complex, you are having the most highest electron density. That means it will be it will be having lots of electron in it, and it can easily donate, it can easily do pi back donation to carbon. Now if it will be doing pi back donation, that means it is decreasing, it will be increasing the anti-bonding electron, so it will be decreasing the bond order. And if the bond order will be decreasing, bond strength will be also decreasing, bond length will be increased, and bond frequency will also decrease. Okay, so that means just find out the order of electron density over here, and you can easily do. So the electron density order will be like, so electron density is highest over here, so this will be first, second, third, and fourth. So this is the order of electron density, whereas what will the order of frequency? That will be opposite of it, because these two things are inversely proportional. So just write the inverse of it. So that means this will be least, then comes this, this, and this. So the correct option for this question will be option number D. So see how simple it is. You just need to understand the pi back donation, electron and electron density on the metal. Then you can find out bond order as well, then frequency, then everything you can relate to that thing. Okay, I'll just give you few more examples in order to make you people understand about it. All right. Okay, so now this question was asked in CSA June 2012, I think, and the question was the it was asked that the complexes of general formula MO, that is molybdenum CO3 phosphine 3, have the CO stretching band as given below. Now you are given with different phosphines here like A, B, C, and D. So A is your PF3, B is your PCl3, then PCl PH2, then your PME3. Okay, so these were 4 phosphines given to you, and different value of stretching frequency was also given, that is 2090, 2040, 1977, and 1945. Now you have to see which combination is correct. Now what you have to do over here, what you have to see is the pi acceptor ability of different phosphines. Now you have 4 different phosphines A, B, and C. So if I write pi acceptor ability, or pi acceptance of the phosphines, then this PF3 will be having highest pi accepting ability. Then comes your PCl3, then comes your PCl and PH2, and then comes your PME3. So this is your pi acceptance ability. Now what this pi acceptor ability will do, see, here is your metal and here is your phosphines. Let's say whatever phosphine you have, and here is your CuL. Okay, so now if phosphine is a good pi acceptor, then what it will do, it will take electrons from metal, it will accept electrons, pi electrons from metal, and metal will be electron deficient. So greater pi acceptor ability of phosphine will make metal electron deficient, or I will say that it will be less, it will not be having that much electron density as compared to this one, which is having least pi acceptor ability. Now what it will do, so if you have more electron density on the metal, back bonding will be more. So that means this, for this phosphine, for this PME3, the pi acceptance is least. That means it will least, it cannot remove much electron from metal. So what it will do, the electron, the metal will be electron rich, like electron density will not be that less, or I would say comparatively electron rich, metal will be electron rich. Now if metal will be electron rich, then the pi back bonding will be more, as I told you that pi back bonding is directly proportional to electron density on metal. Okay, so now, so if the electron density on metal is more, then pi back bonding will be also more, and your frequency, I already told you in the last one that these were related to something like this. then the frequency will be least for this. So that means the one which will be having highest pi acceptability, let's say for pf3, the pi electron density will be least on the metal over here, because it is highly pi acceptor, means it will be abstracting all the electrons from metal, and it will be making metal electron deficient, or I would say less electron density will be there on metal. Okay, so metal electron density on metal will be less, so the frequency will be higher for this. So for pf3, for a, the frequency will be highest, that is 2090. So like this you have to compare them, the relation, like inversely or directly. So electron density less, frequency more. So on the metal, electron density is less. I will just repeat once again so that you can like cope up with it, or you can just understand it once again. See, if the pi acceptor ability is more, if it is accepting electrons more the other phosphines, then what they will do, they will make electron density less on the metal. Okay, so that means pf3 over here at the place of phosphine will accept more pi electrons and will make this metal electron deficient, or I would say less electron density will be there. And this less electron density on metal, will be less, then frequency will be high. So that means pf3, if pf3 will be attached in this complex, then frequency will be highest. So a will be matched with highest frequency, then pcl3, so that comes second one, then comes c for third, and d for fourth. So a1, b2, c3 and d4. So option a gives you the correct match of it. So see how simple concept is there, and like just the way to understand the pi, like pi back bonding, and you can solve every question which can be asked over here. So here now I have summarized the things for you to make the things very simple to understand. Like see, what you have to do, you have to just find out the order of electron density on metal. Now if the electron density on the metal is high, like that will be inversely proportional to your CO frequency. So if electron density on metal is high, CO frequency will be less. That means the order of CO frequency will be opposite of the order of electron density on the metal. Okay, so you just need to find out the order of electron density. Now you know that in metal carbonyl there is one thing happening, that is the bond is also between metal and carbon as well. So they can also ask you regarding the metal carbon frequency. Okay, so what will be the order for that? So that will be reverse of what you all have understood about metal like this carbonyl frequency. Okay, so whatever you have understood till now, just reverse everything, that will be true for metal carbon bond or metal carbon frequency. So the order of electron density on metal will be directly proportional to metal carbon frequency. Okay, so what you have to do now, in order to do any question regarding this frequency kind of thing, any question regarding this frequency, and this will be same for the like carbon like olefin bond as well. Okay, so if you have like C frequency they are asking, C double bond C, then also same thing will be applied. So what you have to do, you just have to find out the order of electron density on the metal, and if they are asking about CO frequency, just reverse it, and if they are asking about metal carbon frequency, just let it be the same. Okay, so I'll just take one question based on this metal carbon bond length, sorry, frequency, and I'll try to explain you guys that how to apply this summarized form. All right. Okay, so let's take this question. The question says that the order of the value of metal carbon stretching frequency. Now they are asking about metal carbon stretching frequency for these complexes. Like one is for vanadium, other one is chromium, and other one is manganese CO6 plus. Follows the trend. So four options were also given in the question, but I have just skipped the options over here. All right. So these are the three complexes, and you have to tell the order of MC or metal carbon stretching frequency. Now I will tell you, like first of all let's find out the order of electron density. So the order of electron density on metal. Okay, so as you see that for vanadium complex the electron density will be highest because it is having negative charge. So electron density order will be same like this, that is CO6 minus, then comes your chromium CO6, and then comes your manganese CO6 plus. Okay, so this will be the this will be the order of your electron density on metal. Now what I told you that the order of electron density on metal, so electron density on metal was directly proportional to frequency of metal carbon. Okay, so in for this question this is the order of metal carbon frequency as well. So if the question is asked, like for this question you can just find out the order of electron density on metal, and you can easily find out metal carbonyl frequency. Now let's see, like if the question is asked about like to find out carbonyl frequency. If that is asked, then reverse this order. That means for carbonyl frequency, the order will become this, that is MCO6 plus will be having highest frequency, and then comes your CrCO6, and then comes your vanadium CO6 minus. So this will be the order of stretching frequency of carbonyl ligand. Okay, now everything you can do from here only. So the frequency and bond order are directly proportional, just remember this. So let's see the order of bond order for CO. Okay, bond order for CO ligand or CO bond order, C double bond O bond order will be having same trend. Now if I ask you about bond strength of carbon oxygen bond, that will be also same, because see, this bond order is directly proportional to bond strength and is directly proportional to frequency. All right, so all these things are directly proportional. But if I ask about bond length, then the order will be different, because it is inversely proportional to bond length. Okay, so bond length order will be reverse of it. So like this you can practice question on all of these things, because sometime they can also ask you regarding bond length or bond order or bond strength. They can ask you that which of these will be having like strongest CO bond, or they can also ask you regarding the frequency. So for finding out frequency, I told you the best way to find out is to find out the order of electron density on metal. If they are asking about CO frequency, then reverse the order, and if they are asking about metal carbon frequency, then let the order be same. Okay, the order of electron density of metal. So that's all for today's class. I hope you people liked it, and I hope you people liked this video. And I'll try to make videos more frequently on YouTube. And yeah, so if you guys have any question related to this topic, you can send those questions to me, and I will love to solve them all. And yeah, you can send those questions on my Facebook page, and you have that link in the description. So just click on that link and you can send those questions to me related to this topic. Okay, and if you want to have some other request regarding any other topic or any other things, you can just write down in the comment section below, and I'll see you guys in the next video. Till then, have a great day, and that's all for today's class. So bye bye, take care.